Well, hello there and welcome back. If you saw the previous video to this, you would have seen me take my top planum off my carbon filter for my laser to mount a extractor fan in the top of it to assist it. So this is the continuation of that. And so what I've done is I've got some 3/4 inch ply, quite nice ply, and I've cut a hole which is about 5 millimeters, about 1/4 of an inch, with larger diameter than the fan. So what I want to do, it's necessary with fan blades to enclose the blades themselves with a sort of a cavity then, or cavity wall that is in close proximity to the blade to stop the airflow actually travelling around the blade. Similar thing to rotor wash, I suppose. So what I need to do now is, out of the same material, I think it's going to be enough. Let's just have a look. So if we measure here, let me see, what do we got? It's about 22 millimeters. So, okay, the very top edge of the blade is going to be proud. And something else I've noticed too, this fan has like a step down, and about 1/4 of an inch, 5 millimeters, from where this is going to sit on top, on the top deck, is a paper filter. So what I'm doing is I'm going to recess this up so this is flush with the material here as it is. So I think it's going to be quite necessary to make a recess into here, just a square one, so the air gets pulled through the entire paper filter, not just in this area. Because if I just put this in, mounted this inside the planum and put it all back together, there's about 1/8 of an inch gap here between the top of the filter and this, which is going to render, sort of the best part of 50% of the filter as not doing an awful lot. So that's going to be counterproductive, I think. So I'm going to take out, 1/4 of an inch or so of this over its sort of that sort of area to be able to utilize the whole of the air filter. So I'm going to go and cut, repeat this cut like I did on the last video, and I want to make another boss to go on here to raise this up, to thicken this up, to enclose all of this. So I'll make that my next 2 jobs and connect it up and see where we go from there. And I've got to design some sort of just small structure to clamp the motor and sort of support it, across the wood there, and probably clamp it here, just with plyboard. It's fine. So okay, that's the next jobs. Okay, so here we are in Carveco Maker Plus. You can do this also in Carveco Maker. So we're going to start a new project, and the measurements are 305. Ooh, that's a big number. So make that 305 and 450. Okay, high resolution, working in millimeters, press, now then. I've drawn this is the actual size of our material. And because I've machined the center out, I'm going to have to now place the datum point or the start of the program in a different area. Okay? Normally with the CNC router, it's in this bottom left-hand corner. So that's what we're going to do. Because the piece of material has the center missing now. So I'm going to press OK. And I'm going to show you a couple of little things here, very simple things. Let me see, so we're going to draw a square over our entire area. Now you notice the target has changed, the cursor has changed to a target there. That's telling me, Carveco's telling me, oh, I found the corner. So I don't have to be very, very precise and go right onto the corner. Carveco has already snapped to it. So draw our squares, and it's snapped to the bottom corner there as well. So release, and it's done it. And there's the measurements up there. I can alter the measurements if I require. And we're going to say create. So we still have that. So I'll cancel that now. Okay. So we still have that selected. Okay. So what I'm going to do is I'm going to say offset the vector. Now, whatever you draw on here, a line, a circle, a squiggle, it's called a vector. So that's what a vector is. It's a mark on the screen, mark on your paper there. So we're going to offset this vector inwards. And we're going to offset it inwards, there, like that. And we're going to give it a distance to offset it now. So I'm going to say 20 millimeters, all right, well, 19 millimeters, 3/4 of an inch. So we put 19 millimeters up there. Oh, actually, I've got to make it a little bit more than that. We're going to make it 25, because I'm going to have a couple of screws. There's already screw holes there. So 25, and 25.4 millimeters is 1 inch. Okay, so I'm going to say down here now, offset. There it is. It's done. So now I'm going to select the, let's get rid of this first. Crossing it a bit. So I'm going to select the outer one now and delete it by pressing delete on my keyboard. So I'm just showing you some simple things here with using the CAD part of Carveco. And you know, this is things that you would do probably when you first get your CNC machine. Just simple pockets. This is going to be a pocket, by the way. Okay, so we highlight that now, and we say, okay, well, we want to machine this. So there's two areas you can go to get into the tooling part of it, and that's either up here in this corner where it says toolbars, or you can get at it from here where it's a 2D toolbar. And this is an area clearance, so that's what we're going to choose, area clearance. And you have this dialogue or wizard now pop up that you just fill in, and you know, it's very easy to do. And start depth 0, so the 0 is going to be the top of our material. Finish depth, I'm going to say 5mm, which is about 6mm. That's closer to 1/4 of an inch actually. 6mm. We're not worrying about allowance because this is just, you know, a bit of wood. Now we're going to add a tool, and we're going to say 12mm end mill, and we're going to select that. So now we can go into here and choose the individual settings for this piece of job. Okay? Or for this piece of work rather. Step over 3 by 6. Well, actually I can go to, I'm going to take that to 4. Probably take a little bit more than that actually. Probably go 5. Like I say, it's only wood. It's not aluminium or anything like that. Step down 3.5. So I'm just going to say 0.0. So it's 3. So it's going to do it in 2 layers. I'm doing it in 2 layers because you know, it won't. You know, I'm going to do it in 1. It's not a, you know, it's not a carving. It's, you know, I'm not worrying about splintering or anything like that too much. So it'll still be a tidy job. So we're going to say we'll do it in 1 cut. We'll do it 6mm. Feed rate. Feed rate can be 50mm a second. That's 2 inches a second. Okay, it's going to be getting along pretty quick. Plunge rate. 20mm. 15,000. I like to run that. Now, if you raise the feed rate, okay, you must raise the RPM, because otherwise the tool and the spindle is going to bog down. If you try and force the tool into the material real quickly, it's going to stall the spindle if you're not careful. So it's necessary to speed the RPM up to cope with the extra speed of travel. So we're going to say 18,000 RPM. The tool number doesn't matter, I don't have a tool changer. I'm going to do an offset, and we're going to do climb milling. And we're going to start on the inside workout. That's fine. No need for a ramp in because, or anything like that, because there's nothing there in the middle. Okay, so it really doesn't matter to us. So it's going to quickly sort of run around in the air and then start cutting the material. Okay, let's set up the material thickness now, and I know that's 18mm. 18mm. Zero's at the top. Okay. Okay, so it's going to be this is a test cut. And we're going to say this is 12mm E-mill, 12mm end mill. So I just abbreviate everything. So long as you can understand what it is, it's fine. So we're going to calculate that. Boom, done. And you know, if we wanted to, we can simulate that. So what we're going to do, we're going to alter the view to an, I think that's called an isometric, and then we're going to press simulate, standard settings, simulate. Boom, done. There it is. And we can actually turn on the material and turn on the tool paths. So you can see, well, okay, there's the tool paths, that's what's going to happen. So now I'll transfer this into Mach3 and we'll get set up and cut this. Okay, here we are in Mach3. So I'm just going to show you a couple of little things here. Now, first of all, this is left over from the last job that I did. So what I'm going to do is close this G-code file. So it's deleted it now out of Mach3. And I'm going to come up here and load G-code. There it is there. And it's in there. The Mach3 still doesn't know where it is at the moment. So what I'm going to do is I'm going to come here to the machine home. I'll show you where the machine home is now. So this is the machine home position. As far forward as the gantry can come and as far over to the left hand side as the router head can go, and up as far, nearly as far as it can go. This is the most convenient area to change a tool. Very convenient here. So this is the machine home. Now we're going to make the start of the program in a minute and find the 00 start of the program, which would be in the bottom left hand corner of our piece of material that we got on the deck. So we'll do that next, and I'll just put this tool in here. So what I'm trying to do is visualize the center of this tool right into this corner here. By eye is okay. Within sort of 0.5 millimeter, that's just fine. Okay, let's just take the Z down now. Okay, that's done. So it's just touching the material, and the center of the tool, if you can visualize it, is just on the edge of that corner. So now we'll go back to Mach3 and we'll set the zeros. Okay, so we'll get the cursor now and come here to the X, Y and Z little buttons and go X0. Oh, that's better. So I was still in machine coordinate there. So X0, Y0, Z0, and what is very, very important here is to go to the regen button, push that, and you'll see that the work and the work itself and the tool position will jump into the correct location, you know, on this table. This represents my table, so that will jump there. So now we will I'll just raise the tool up off the material and we'll set the cut going. Just a light sanding just to clean the edge up. Look at that. Does a beautiful job, doesn't it? And easy. Okay, that's that piece. And of course, this piece. So now we have there we go. So now what we need is a bar across here, a shaped bar, with a hole cut out of it in two halves, so I can sort of screw onto here and then screw together to clamp this motor in place, and you know, sort of getting it sort of square in there, nice and round, so it doesn't touch any of the edges. That'll be fairly easy as well. Okay, so I think the next job is I'll screw this to this piece. Oh, I might glue it actually. Yeah. I'll then draw up in Carveco the more complicated piece to go on the top of here. Okay, let's do it. So now we're going to start a new job, and to do that you come up here to this top corner to File, press that, New. So our new piece of work is, oh, it's already set there in the X, which is 305 millimeters, just a little over 12 inches, and this one is 145 high resolution millimeters, and now we want the center. So So that's the center origin of our job. I'm going to say and no, I don't want to save. That was just asking me if I wanted to save the previous project. No, I didn't. Okay, so right in the center here, the armature or the body is 78 millimeters in diameter. So first off, we need to get the circle drawing tool, come to the center, and it'll snap. It'll come out. And we want to say we want this diameter 77 and create. So the next thing I want to do is close that, and I want to draw another circle. So come here to the center, and I want that one to be, let me see, 77. I want that one to be 120. And create. And then I want the square, and I want to draw a rectangle over the entire piece of material. So I want that to be 305 long, and I want it to be 40 millimeters wide. Actually, I'm going to make it 45. Give it a little bit more meat. 45. Now, I want to position this accurately in the middle, right? In the middle of this square box. You can just simply just press 0 on here and 0 on here, because we know that the center of the job and the work and the model is x0, y0. So you just do that and create, and it's done. And that's perfectly in the middle. So now what we're going to do is we're going to get our clipping tool. I'll show you what we're going to do with that. Okay, so over here you'll find a pair of scissors. This is a vector clipping tool. And we're going to do exactly that. We're going to clip that, and clip that, and that one, that one, that one, that one, that one, and that one. And there is our shape. Now what I'm going to do is I'm going to get the CNC router to cut this center out, then run around this outside and cut that shape out. And then I'll just stick this shape then on my saw and just slit it down the middle. So then I have the gap that I require, which is going to be 3mm. And I'll have two halves, and I'm going to put a hole through so I can screw it together and clamp up on the body of that fan motor. Simple as that. It doesn't have to be complicated. So we highlight this, and then we go into toolpaths, 2D profile. I could do an area clearance or a profile. It's just easy for me to do a profile. And so I'm going to change this from the outside of this line, I'm going to say I want it inside of the line. So I want the tool to run around the inside to give me the correct size then. None of this really matters to us anyway. Start depth 0. 0 is going to be on the top of the material. Final depth, because I want to cut right the way through, so I'm going to say 19 millimeters. Select a tool, 8mm end mill, select that one. Okay, step over. Look, step over doesn't matter to us because we're just going to do a single contour. Step down 2.5. Actually, we can go 3. We'll probably go 5 without too much difficulty. We'll go 4. 4mm speed. Now, I'm going to do 50mm per second, 2 inches per second. Plunge rate, I normally do the plunge rate about 50% of what the feed rate is. So it's 25. I knock this up because I've speeded up the feed rate. Don't forget, you've got to speed up the RPM, otherwise the tool will bog down. That's okay. Climb milling, that's right. Now, for this time, I'll require ramp moves. Now, I normally zigzag, so in other words, it'll do this and ramp in. That's exactly what we want to do. No, I don't really require. I don't require these. So, really don't require those. Not for this job. Safe said 10mm. Let's just see what they got with the material. We're going to say this is. We're going to say it's. We're going to call it 19. Save any dramas, even though the material is 18mm. We know that we're going to go through to the spall board. Okay, that's that one done. I'll name it, and we're going to say cut 1. Calculate now. Boom, done. Get rid of that. Now, separate job now. Another profile. Outside, so this time we're going to run. Well, we better select that first. Okay, so there's our tool path. And what I'm going to do is come out of that, and I'm going to go in and edit the first tool path that we did. That's easy, just double click, edit the first tool path, and we'll put, oh, I did already do it. Okay, no problem. Okay, so we'll select an isometric view, and we will run simulation up on all of them, on all tool paths. Oh, there we go. So that's the shape that we're going to end up with. So I'll just transfer that file over to the CNC router now, and we'll cut it.